students, welcome back. Today I'll go with physics session. Okay, in my previous video I have explained about resistance, resistivity, Ohm's law. Today I'll continue with how the resistances are connected. That is how we can, when we are connecting so many resistance, then what will happen if we are combining these resistance. Now there are two connections are there that the resistors could be joined. That is, one is series combination and the second is parallel combination. Correct? Now, shall I start? Yes, come. Now, first series combination and the parallel combination means these are the resistors or the resistances. When they are connected, then we are call it as a series or parallel. Now, first I'll go with series combination. In this, what happens? This is the circuit diagram and this is the current, which is the battery, and the current is flowing from here. I just want to recall you about current means the charge which is flowing in unit time. Potential difference, it is the amount of work done to carry the charge from one point to another. Resistance, to oppose the current, that I have put it over here. Clear? Now, we are joining these resistance in series. That means, suppose this is one resistor, this is R2, this is R3 with the same battery. Now see what is series combination. When this current is flowing, this is the current, to this end, that is the resistor starts, and up to this end. Then again to this end, the current is flowing, again to this end. That means this is end to end. Current is flowing end to end of the resistor. This is one end and this is another end. Clear? So when the current is flowing end to end resistance with the same wire on the battery, then we will say it is the series combination. It is not necessarily 3. You can take any number of resistances connected to this, and every resistance can be connected to the gadgets. Maybe refrigerator, bulb, tube, any gadget you can use in any of them. Now if I say when the current is flowing, student, now current here, charge flows from here, then it is opposing this charge, next resistor, next resistor. That shows that I is constant. I is constant, that is the same current which is continuously flowing through it. Then what happens? The current remains constant. If the current is 2 ampere this side, there will again 2 ampere until or unless it will reach here. And how will we come to know whether it is a 2 ampere? This is the ammeter connected over here to measure that 2 ampere. Clear? Now, if I say the voltage. Now, what is series then? What is series? This is a law of combination of resistances. The series combination means, according to this law, the combined resistances of any number of resistances, that means in series, are equal to the sum of individual resistance. When we add it up all this resistance and the answer comes, then it will be series combination. Sum, when we are summing up all this. Clear? When we are summing up the resistances, the total resistance which we will get series combination. And we'll find that series combination, always the value is more than that of the parallel combination. How it happens? Now first, the formula we have to find how the derivation is there, how this formula. Initially I told you that current remains constant throughout. That means if I set up the voltmeter, and what is voltmeter? To measure the potential. Now if and voltmeter which measures the potential difference. Now if I am connecting, and voltmeter is always connected in parallel combination, and ammeter is connected in series combination. This is called parallel to the resistor. Now if I arrange the voltmeter and parallel to the resistance it is connected. So this is V1, this is V2, this is V3. What happens when the current is constant, but what is potential? It is the work done to carry the charge. How much work is done to carry from here to here? This we are measuring over here. Suppose if I say I have started with a battery of 6 volt. This is the 6 volt battery I have taken. Now we will check it out what happens and what is the reading in V1, V2. Suppose if I say 6 volt battery and 1 volt it is consuming. This resistor is consuming, suppose 3 volt. 3 volt, and this is consuming 2 volt. And when we add it up, 2 plus 3, 5 plus 1, 6, always equal to this. That means total 6 volt we have started and the resistances are consuming according to that, and that reading will come in the voltmeter. So that means what we are concluding here, volt is dividing, that means potential difference is dividing. If I say V is equal to V1 plus V2 plus V3. Any number could be possible, but here I have taken 3 voltmeter. 3 voltmeter in which we are getting this reading. Now by Ohm's law we know that V is equal to IR. Correct, student? V is equal to IR. If I put this IR in place of V, means we are giving relation to the current flowing through the resistance, because this is variable. So if I put this value over here, then we get IR total is equal to IR1 plus IR2 plus IR3. And if we take common, I common because I is constant, so R1 plus R2 plus R3. Right, student? So cancels. So R is equal to sum of the individual resistances. This is the law says, and this is the formula to find the resistance in series. Clear, students? This is how the derivation, this comes for 2 marks in your board, but you have to write the law, and this is the derivation. So what is the formula finally? Series is equal to sum of, see, the combined resistance of any number of resistances in series are equal to the sum of individual resistances plus any number. That means plus ... any number could be added. This is called series combination. Clear? So now I am switching to the parallel combination. Come. Now what is parallel combination? In parallel combination, it is a reciprocal of the combined resistance. What is the meaning of reciprocal? 1 by. Clear? It is a reciprocal of the combined resistance of any number of resistances when they are connected in parallel. This is known as, and that parallel is equal to the sum of the individual resistance. How it happens? Suppose if parallelly I am connecting, this is a circuit diagram. This is battery, positive, negative, switch, and this ammeter to measure the current. Now, if I say I have taken 3 resistors, R1, R2, R3. Right? This is the current flow. Current. Now what happens? See, this is not end to end. All the ends of these resistors are connected to one point. This is one point. Then they are connected to the battery. So what happens then when the current is coming? Current is flowing this side and this side. That means I1, I2, I3. Current is dividing. Here, where there the current is constant, here the current is dividing, and volt has to be kept constant. Then it will be the parallel combination. It is connected in parallel, which is joined at one point, which is connected to the main volt battery. That means when the current is flowing through here, what happens? The current is dividing. If I prove this by Ohm's law, then what will we see? Here V is equal to constant. This is the main point you have to remember. I constant in series and voltage is constant in parallel combination. By Ohm's law, and current is dividing. That means I have taken 3 resistors. So I1 plus I2 plus I3 current divides. Right? Now if I say, we have to find the resistance, the relationship between the voltage, current and relationship. By Ohm's law, we know that I is equal to, yes, V is equal to IR, then I is equal to V upon R. Correct? Now, instead of I, I'll put this value. So, V by R is equal to V by R1 plus V by R2 plus V upon R3. Now, volt is constant. So, next 1 by R, P, that is parallel, V common and V by R, 1 by R1 plus 1 by R2 plus 1 upon R3 and cancels. So, 1 by Rp is equal to the reciprocal of all the individual resistances combining together is called parallel resistance. This is called parallel resistance. See, the reciprocal of the combined resistance of any number of resistances parallel to the equal to the sum of the individual resistances. This is called parallel combination. Clear, student? The only thing you have to keep in mind, series end to end it is happening with the resistance. In parallel, it is single point. All are connecting at single point and the current is divided. Right? And when we find the value, we will also find that in series the value is always more. If the series, the parallel is more, the value is more, suppose if I say 48 ohm, and in parallel the value always comes in the less number. That is, suppose if I say 6 ohm answer. So what happens then? RS, RP. Here the value is more. We know by Ohm's law that R is equal to V upon I. It is inversely proportional. If RS is more, then current will flow less. So, is this advantage? And if I say RP, if I say this is, I am talking about RP, the value is more, the current is less. In RP, the current is 6 ohm. If I say this is the resistance, the answer is less. If the answer is less, then current will flow more. And that is why the more amount of current is passing through parallel resistance, that means, yes student, this is more advantageous than this because more amount of current we are getting from here. Right? Now, what happens? The advantage of parallel combination. In this, if one appliance stops working, another appliance will keep on working. Clear? Another one switch. And if each electrical appliance has its own switch, means it is not necessary that every room the parallel combination is going and every room, every gadget has its own switch. This is very, very important again. And the third part, what is that? The voltage is constant, which is 220 volt. That is the domestic appliance. Domestic voltage that is passing through is 220 volt. Which is going to, because it is constant, that is we are using 220 volt for parallel connection. Clear student? This is how. Now next, a little bit, let me explain about the questions which are coming through. Suppose if I take one numerical, this is series combination. Suppose this is the combined series and parallel, I am making it together. Clear? And this is the circuit. And positive, negative, suppose 6 volt. This. And ammeter to measure the current. Clear? Now current is passing through. What happens? Here both the cases are there. Series and parallel. If this kind of numerical comes, then what will you do? Suppose if I say 2, 4, 2. Clear? Then what will happen then? First we have to see which are in series combination and which is in parallel combination. See student, this is end to end. That means this is series combination. So first step, we have to find series, that is 2 plus 4 is equal to 6 ohm. And this is connected to the parallel of 2 ohm. 2 ohm. So Rp is equal to 1 by Rp, in fact 1 by Rp is equal to 1 by 6 plus 1 by 2, and then you find the answer, and the Rp, then the answer will be reciprocate, you will get your. This is how you can go with all these numericals. I'll take one numerical session students, in that I'll explain you about all this. I'll take one numerical session of the electricity. Today, series and parallel is clear, students? Clear? Any of the doubt, you can please write it in my comment section. Thank you so much for liking my videos. That gives me moral booster. So please subscribe, share and like. Thank you, students. Thank you so much.